Let's today discuss about the second topic of our design verification crash course module, which is explaining by me as an graduate student in this series of lectures from my YouTube channel. So today our topic is going to be assertion-based verification. Its short form name is ABV, and it is ensuring the design correctness, which is used for the SystemVerilog assertions in order to check the its behavior is correct or not, whether the design is going to be good. And this is the basically a master topic in our electrical and computer students, and it is going to presented by me today. Hello everyone, today is my lecture 2. Okay, coming to the introduction, it is ensuring uh, it is having the design verification. The specs are going to be corrected, and the traditional test benches behavior is going to be added, and there are some corner cases which is hard to touch. Those also will be explained. Like we are going to ensure that the design behaves correctly under all the scenarios. The traditional simulation alone often misses corner cases. Assertions are a way to continuously check the behavior against the specification, giving us faster debug and more confidence. Like, what is an assertion? Let's talk about the definition. An assertion is going to be a statement of expected behavior in a design. Think of it like a contract. If a condition is true, then the another condition must follow. In SystemVerilog, assertions are written as SVA. So that is the name. The title is going to be SystemVerilog assertions. So, for example, if I press an elevator button, I expect to elevator to eventually arrive. Like similarly, if I signal request goes high, we expected a grant signal should follow. So in this entire lecture, we are going to have a request and grant as an parameters, for which we are going to use that one in our discussion in the examples of the properties in this. So coming to the types of assertions, we are going to types of assertions. Assertions are classified into two types. One is immediate and one is concurrent assertions. In immediate assertions, it is going to check instantly, useful for combinational logic or single cycle conditions. In a concurrent touch, it will check multiple cycles using temporal logic, like request followed by grant after one cycle. Not like the same as immediate assertions. Suppose in addition, in an industry, the concurrent assertions are heavily used for protocols and handshake checks. So because the concurrent will be followed by the next signal, so this is the one which is necessary in our industry. Okay, why we will use the assertions? So basically, these assertions are good when we catch the bug in an early stages to the source. They improve the observability and they reduce the debug time, and also they ensure protocol compliance. So protocol compliance is going to be so for a specific design, we are going to have some set of rules. Those set of rules should be followed by the design. So, and also they complement the coverage by telling us not just that an event happened, but whether it happened correctly or not, so that the quality of the design is going to be increased, and this is going to be benefit for the company as well, because in the early stages of the verification, if we found the bug and we detected it correctly and then we went for validation, it is always better for the cost saving purpose of the company. So when it comes to simple assertion examples, so suppose the handshake protocol, the request is going to be followed by the grant. And when suppose if you take another example, request goes high, the grant should come in the next cycle. And also there is a FIFO example as well. If the FIFO is not going, the FIFO and empty is not going to full, that's the assertion. So let's go put a request pass. A request pass happens when the assertion condition never gets triggered. So, for example, if the antecedent and coincident are the two things, the request never occurs, the property technically passes, but tell us nothing about correctness. That's why we always have coverage to ensure the condition is exercised or not. So, coverages are the most important thing in this one. Without the coverage, always there will be a request pass. So, So ABV in the simulation, okay. So assertion-based verification in the simulation, it's a dynamic checking. Assertions run alongside the test. They continuously monitor the signals. If a failure occurs, simulation logs an error immediately. This helps reduce the reliance on scoreboard only checking and speed up debug. So entirely we can get the failure point. So the ABV in the formal verification, it highlights the properties to prove correctness mathematically, and the formal tools are there in the exhaustively. We are going to check all possible input scenarios. If a assertion fails, we get a counter example. We get a counter example trace. If it hold, we gain high confidence the design is correct. Otherwise, we are not going to get the fairness of it. And coming to the advantages of the APV, it's clear advantages are there in the industry. Like it will detect the bugs very fast, and it improves the observability and the coverage, and also it's live documentation of a design intent, and it works for both simulation as well and formal force as well. And it scales in the complex protocols as AXI, DDR, and PCI protocols. There are some challenges in the ABV as well. So of course, the main challenge is going to be writing assertions requires skill in temporal logic. Too many assertions can slow down simulation sometimes because they have to check the more assertions instead of the design which is simulated. And vacuous passes can give a false sense of security as well. And engineers need training to fully use SV effectively. So suppose this is a request and grant handshake protocol. Whenever request goes high, grant should follow in the next cycle. If this fails, the tool throws an error message. This simple property ensures handshake protocol are always respected. And at the same time, if the FIFO full and empty, suppose let's talk about this, full and empty signals should never associate at the same time. This property checks for mutual exclusion. If both are high, it indicates a serious debug, and assertions make sure the conditions are continuously monitored. And it is going to be back-based pass. Back-based pass. Suppose here the property says A happens, then B should follow. But if A never happens, the property passes backwardsly. That's why we always add a coverage property to check whether the A actually occurred in simulation time or not. And when it's checking to the SPA and check code, uh, this is an actual SVA syntax. The request followed by after one cycle the grant should come. The symbol means the implication operator, and one cycle later it should come. So this is how we capture request followed by grant in SystemVerilog by writing these assertions. Like we will have handshake grant as a property, and in that there is a disable signal, and if it is not going to reset, and then the property is going to happen, then we are going to call that one, and there is an error message saying that the request is not followed the grant. So we are going to write the property and we are going to call the property. That's how it will work. So this is the same thing for this FIFO, and also both nodes should come the same time. So we are going to write the property and we will going to accept the property. backface pass as well. So A, so here is the assertion checks A and B, but we also add a cover property. Make sure that A should come at least one time to ensure the antecedent will be exercised. So in conclusion, the ABV is now an industry standard. It ensures the protocol correctness and captures corner cases. It complements UVM, formal verification, and coverage-driven verification. Looking ahead, we might need to integrate AML to automate the generate assertions as well. Okay, thanks for watching my video. Wait for my next video. Have a good day. So I can say stay tuned to just wait for my next videos. We'll dive into the real more descriptions of the assertions maybe soon, but let's hope for the best. I hope everybody got idea on these things. So if anybody have any questions, please go on and put a comment on under the video so that I might get notified and I will give the clarity. So these handshake protocols and uh, property writing and the backface pass are very important in this one.